For the longest time, we've thought of AI as a student, and we're the teachers. We feed it data, we label that data, we tell it right from wrong. But what happens when the student suddenly learns how to write its own textbooks and then create its own final exams? We're going to dive right into this, because this is the next frontier of artificial intelligence, models that can literally teach themselves.
And this is the central question, isn't it? Can an AI really reach new heights of intelligence if it cuts the cord from us, its human creators? It's a question that researchers aren't just asking anymore. They're actively trying to answer it.
So, first things first, we need to understand the problem. Why do we even need an AI that can teach itself? Well, it turns out our greatest strength, all of our collective knowledge, has also become AI's biggest limitation.
Just think about it for a second. Every single piece of data that was used to train a massive model like GPT-4 had to be created, cleaned up, and often painstakingly labeled by a person. It's like a giant anchor, tying AI's potential to our own level of understanding. We simply can't teach it what we don't know ourselves, and the whole process is incredibly slow and expensive.
And hey, don't just take my word for it. The researchers behind one of the methods we're about to look at, R0, they put it this bluntly. This human bottleneck isn't just some small inconvenience. It is the fundamental barrier that's preventing AI from reaching its true and possibly superhuman potential.
Okay, so how do we break through this bottleneck? Well, the first really clever solution involves a model learning to create its own feedback loop, basically becoming its own teacher and student all at the same time. It all starts with a technique called direct preference optimization, or DPO for short. Now, in the old days, you needed a whole separate AI model just to sit there and judge the main model's answers. But with DPO, the model itself develops its own internal, implicit reward model. Think of it like an internal sense of taste. It learns to recognize what a good response feels like, all by itself, without needing that separate referee. This leads to this absolutely brilliant self-improvement loop called DICE. Let's walk through it. First, the model spits out a bunch of different answers to a single question. Then, and here's the magic, it uses its own internal taste, that implicit reward model, to rank its own answers from best to worst. That ranking becomes a brand new lesson plan. The model then retrains itself on the lesson it just created, making it just a tiny bit smarter. And then, it does it all over again, and again, climbing a ladder of its own making. But what if we could go even further? What if an AI didn't just refine the answers it already came up with, but could generate the entire curriculum, both the questions and the answers, from absolute, total scratch? This is the incredible idea behind a framework called R0. It's based on this concept of self-play, which you might have seen be incredibly successful in games like chess and Go. The idea is you start with just one base AI, but you split it into two different roles that are going to work together and also kind of against each other to get smarter. So, meet our two players, the challenger and the solver. The challenger's only job is to dream up new problems that are perfectly difficult for the current solver. Not too easy, not too hard. You can think of it like a personal trainer. And the solver? Well, its job is to do the push-ups, to get stronger and stronger by tackling the exact challenges its trainer designs for it. And what you see here is this really powerful coevolutionary loop. You start with just a single base model, that simple llama on the left. It then splits and evolves into two specialized versions, a challenger that gets better at creating really tough problems, and a solver that gets better and better at cracking them. The solver's solutions then become the training data for the next generation challenger, and on it goes. They're locked in this amazing dance, literally leveling each other up with every single cycle. Now, this all sounds incredible, but there's a hidden danger lurking in self-improvement. When an AI only listens to itself, it runs the risk of getting stuck in an echo chamber, becoming repetitive, and losing the very creativity we're trying to build. Researchers have a name for this: entropy collapse. And it's a really fascinating way for things to go wrong. The model might actually get better at finding one single correct answer. That's what's called pass at 1. But its ability to find lots of different correct answers, or pass at n, starts to shrink. It just forgets how to explore, and its creativity collapses. And here's what that collapse actually looks like. So on the left, you've got the model before this intense self-training. Both its pass at 1 score for finding the single best answer and its pass at 16 score for finding diverse, creative answers are looking good. But look what happens on the right. After it gets stuck in its own echo chamber, something dangerous happens. The pass at 1 score might stay high, but its creativity, that pass at 16 score, has absolutely plummeted. The model is becoming a one-trick pony, and that's a huge problem.
So how in the world do you prevent this? Well, another group of researchers developed a framework called EvoRL, and their solution is just beautifully simple. They look to the most successful learning system we know of, biological evolution.
EvoRL works by balancing two crucial forces. First up, you have selection. This provides stability. The model gets a reward for finding the most popular or consistent correct answer. But, and this is the critical part, it also balances that with variation. The model gets a totally separate novelty reward just for finding new ways to reason, for exploring different paths to the same solution. It's a system that brilliantly rewards being both right and creative.
So, what happens when you put all these powerful ideas together? Well, the implications for the future of AI reasoning are, frankly, profound. We're not just talking about better chatbots here. We're talking about a whole new way to build intelligence.
And this isn't theoretical. It actually works. Just take a look at these numbers from the R0 paper. After only 3 iterations of this self-play, the base model score on complex math problems jumped by over 5.5 points. On MMLU Pro, which is a really tough general reasoning benchmark, it improved by over 6.4 points. This is a real, measurable leap in capability, and it was achieved without a single new piece of human-labeled data.
And that right there is the ultimate takeaway. These self-evolving systems are not just memorizing more information. They are building a fundamental, generalized skill of reasoning. They are literally learning how to think. And as those results show, a skill learned in one area, like math, can successfully transfer to boost performance in completely different domains.
And this brings us right back to our big question, but maybe with a bit of a new perspective. We are witnessing the very first steps of an AI learning to walk on its own, creating its own map as it explores. So if AI can truly forge its own path to intelligence, completely independent of its human teachers, the profound question we're left with is, where will that path ultimately lead?